The Charpay Impact Test. The standardised Charpay Impact Test has been designed to measure the toughness of materials under impact loading and multi-axial stress state. A pendulum impact testing machine is used to do so. The pendulum on the machine has a heavy weight at the end. This is lifted into the starting position in step 1. Then the tester checks whether the testing machine has been adjusted accurately. In order to do this, he turns the drag indicator downwards and releases the pendulum without a test specimen. The drag indicator stops at position 0. This proves that the pendulum has the correct starting position and that the friction is correctly compensated. The machine is ready for the tests. First test, strain-aged plain carbon steel S235. This is our test specimen. It has been machined to standardise size and shape with the characteristic V-shaped notch. The tester places the specimen on a support in the lower part of the machine and adjusts its position with a centering device. Next, he turns the drag indicator downwards again and checks that everything is prepared correctly. Perfect. The test can begin. The pendulum is released, it swings downwards and hits the specimen with its rounded hammer peen. The specimen absorbs part of the pendulum's energy, so the pendulum doesn't reach the full height on the other side. The amount of energy that has been absorbed by the specimen can now be read off at the position of the drag indicator. It only amounts to 13 joules in this test. Here is the main principle of the measurement. In its starting position, the pendulum only has potential energy. It is given by mass of the hammer m times gravitational acceleration g times starting height capital H. After the pendulum has been released, the hammer moves downwards, hits the specimen and then only swings to height small h. Exactly at the first reversal point, the pendulum again only has potential energy, which is m times g times small h. The energy that has been absorbed by the specimen is called notch impact energy, kV. It corresponds to the difference between the two potential energies. The first specimen only shows very little plastic deformation. A mostly flat, slightly glittering fracture surface has been formed. This is another important indication that this kind of steel is only able to absorb small amounts of notch impact energy. It shows mainly brittle behaviour due to the strain aging effect. Second test. The second specimen has been made from normalised steel S235. It is also placed on the support and centred. The tester turns the drag indicator to its starting position, rechecks all safety measures and releases the pendulum. This time the impact sounds much deeper and richer. An impressive energy of 182 joules has been absorbed by the specimen. Here the specimen did not break into two pieces. Instead it was pushed through the counter bearings under heavy plastic deformation. In comparison with the strain-aged steel, the normalised steel absorbs much more notch impact energy and behaves in a very tough manner. The Charpay impact test is not only carried out at room temperature. Materials with body-centered cubic crystal structure, such as plain carbon steels, show a characteristic S-shaped curve of the impact energy versus temperature. In the so-called upper shelf region, the material absorbs a lot of energy and behaves in a tough manner. At low temperatures, in the lower shelf region, only a small amount of impact energy is absorbed and brittle fractures occur. Metallic materials with a face-centered cubic crystal structure, on the other hand, do not experience a ductile to brittle transition. These materials retain their ductile behavior towards low temperatures and are therefore well suited for low temperature applications.